Hello guys, welcome to the lab. In today's video, we are going to control the brightness of these LEDs using this rotary encoder. And by pressing the switch of this rotary encoder, we can toggle among the three LEDs red, green and blue, right? So let's start building this project. Now let us discuss about the pinout and the internal structure of this rotary encoder. So in this encoder, as you can see, it has 5 pins, right? Clock pin, which is represented by letter A, DT pin, which is represented by letter B, switch pin, VCC and the ground. And in this image, as you can see, it has 3 pins, A, B and C, right? So AB remains fixed, but the clock pin comes in contact with the pins A and B whenever we rotate the knob of this encoder clockwise or anti-clockwise, right? And A and B pins output the digital pulses on the rotation of this encoder. So on the clockwise rotation, pin A leads B, and on the anti-clockwise rotation, pin B leads A by 90 degree, right? So there is a 90-degree phase difference between both the pins. So in this demonstration, as you can see, on the clockwise rotation of the common pin C, the output A leads the output B by 90 degree. And similarly for the counterclockwise rotation, the output B leads the output A by 90 degree. And whenever we rotate the knob of the encoder, we are actually rotating the common pin C, right? Now this is a table for a reference to check the values of clock pin and the data pin on each step of rotation, right? So these step 1, step 2, step 3 are the steps of rotation of the encoder. And whenever the clock pin and the data pin comes in contact with the common pin C, they output one value, right? And whenever they lose contact with the common pin C, they output low value, that means 0. So if you are following me till now in this video, subscribe to my channel and like this video so that you will keep on getting these kind of projects in future as well. Now let's discuss about the program to control the brightness of all the three LEDs. So we are defining all the 3 pins of the encoder, CLK pin, DT pin, switch pin and all the 3 LEDs. And note that these pins 5, 6 and 9 are the PWM supported pins. I've already told you in the starting of the video. And we are defining the initial value of brightness as 0, right? And we are also required to define one variable called last clock state to decide whether the rotation is clockwise or anti-clockwise. You can also define the last DT state, right, as I have defined in this program also, right? I will show you this program later on. First of all, let me complete this. And we are defining the current color variable. So 0 will be for red, 1 will be for green and 2 will be for blue. Now in the setup section, we are defining pin modes for all the pins defined above, and clock pin and the data pin are defined with the input mode, but the switch pin is defined specifically with the input pull-up mode. Now you may ask why we are not defining clock pin and the data pin with the input pull-up mode, right? And the reason for this is that whenever we work with the devices like push buttons or switches, which are the mechanical components and they need to be pressed, okay? So due to debouncing effect, they sometimes give wrong readings to us, okay? And whenever we do not press these components, they remain in floating condition. Floating condition means they sometimes randomly pick signals from the microcontroller and give us unnecessary readings. So to prevent those unnecessary readings, we use this input pull-up mode. So this input pull-up mode keeps this switch pin high whenever we do not press these buttons, so preventing the floating condition. But the clock pin and the data pin are already connected to the ground and the VCC through the internal circuitry of the encoder. That is why they don't need the input pull-up mode, okay? As the encoder already provides them the stable high and the low signal. And all the LEDs are connected with the output pin mode. And in the setup section, we are already reading the digital state of the clock pin and storing that state into the last clock state variable. You can also use last DT state in the setup section as I have done in this program, okay? I will come on this program later on. First of all, let me complete this. Now coming into the loop section, here we are reading the digital state of the clock pin and storing it into the current clock state, which will be further compared with the last clock state to determine the direction of the rotation, right? So in this section we are determining the direction. So if the current clock state is not equal to the last clock state, it means that the state of the clock pin, which is represented by the letter A, has been changed, and current clock state is equal to high means that the clock pin is in contact with the common pin C, right? So this happens in two ways, either with the clockwise rotation or with the counterclockwise rotation. So if the digital read of the DT pin is not equal to the current clock state, I am defining this case as a clockwise rotation. You can also define as a anti-clockwise rotation. It depends on you, right? So on the clockwise rotation, I am increasing the brightness by 10. Otherwise, I am decreasing the brightness by 10 for the counterclockwise rotation, right? And if the brightness is greater than the 255 value, I am constraining that value into the between the values 0 and 255. Now we are further inputting this brightness variable into the update LED function, right? Now let's understand this update LED function. So in this function we are using analog write function on all the three LEDs, red, green and blue. Okay. And if the current color value is equal to 0, it means that if there is a red LED, then write the brightness value on that LED. Otherwise, write the value 0 on that red LED. It means that turn it off. Okay. And similarly for the green pin and the blue pin. So this is the ternary operator. Okay. If there is a specific LED chosen, write the brightness value on that LED. Otherwise, turn it off. And after this if condition, we are updating the last clock state with the current clock state for the next loop iteration. And in this section we are updating the color of the LED. So if the digital read of the switch pin is equal to low, as I have already told you that whenever we press the switch, it reads low, otherwise it reads high. So low means that we have pressed the button. So after the delay of 200 milliseconds, which is a debounce delay, we are updating this current color value by 1. Okay. And if the value is greater than 2, then we are setting the current color is equal to 0, because we have only 3 LEDs. Okay, which is also called the cycle back to red. And we are further calling this update LED function to change the uh, LED from red to green, green to blue and blue to red. Now in this line we are defining one infinite loop to run. Now in this line we are defining to wait until Now in this line we are defining one infinite loop to wait until the button has been released, right? So this while loop will run until this condition remains true, right? And lastly in this code we are replacing the current clock state with the current DT state and last clock state with the last DT state. You can cross check between both the programs. And the necessary changes have been done in this part of the code. So in the previous code, if you remember, we have written the digital lead of the DT pin is not equal to the current clock state, but in this program we have written digital lead of the clock pin is not equal to the current DT state, right? And brightness level is being decreased on the counterclockwise rotation, right? So the brightness is increasing on the clockwise rotation and decreasing on the counterclockwise rotation. So if you enjoyed this video, hit the subscribe button and share this video, and also tell me what next project do you want from me. And if you have any doubts regarding this project, let me know in the comments. We will meet with a new project. Till then, goodbye.